Contemporary Physics Top 100 Dilemmas. Episode 2. The Problem of Gravity's UV Completion and Nonperturbative Definition. Picture the microscope being tightened harder and harder until you are no longer looking at gentle ripples on water, but at tsunamis, boiling surfaces, pressure cookers, black hole edges, and critical phase changes where the whole substrate is going wild at once. That is the plain language heart of the problem. UV completion asks whether a theory of gravity can keep its footing as you drive the scale shorter and the energy higher, instead of dissolving into formal infinities right where the question becomes most serious. The nonperturbative problem asks what you are supposed to do when the system is no longer a calm surface that can be described by tiny corrections, but an entire machine flipping, reorganizing, and rewriting its own rules in one violent regime. Many theories look elegant on calm water. At the shortest scales, strongest couplings, and most extreme boundaries, they can start to resemble a ruler built to measure little ripples being forced to diagnose a waterfall. The ruler begins to shake apart before the waterfall has even been understood. That is the deep unease mainstream physics has with gravity. If you keep asking shorter scale, higher energy questions, does gravitational language become more fundamental, or does it crack under your feet first? When general relativity is pushed through the ordinary perturbative quantization strategy of field theory, the method effectively assumes a background that is mostly tame and then tries to build the full answer from layer upon layer of small fluctuations. In weakly disturbed windows, far from extreme conditions, this is immensely powerful. But near black holes, strong boundaries, critical layers, violent collapse, and severe strong coupling rearrangements, the weakness of the strategy becomes obvious. The system in front of you is no longer a sum of tiny repairs. It is the whole pot boiling at once. Then divergences, anomalous terms, and the failure of simple closure start to surface together. Mainstream physics ends up saying two things at once. General relativity is extraordinarily successful as a low-energy theory, and the deeper definition still has not been delivered. Matters get worse because there is still no widely accepted answer about what the nonperturbative ontology of gravity even is. Should the deepest object be a point, a string, a network, a geometric state, or something else entirely? It can feel like several teams are trying to sketch the same storm from different shelters, each drawing a beautiful partial map, but none of them cutting open the machine and laying the mechanism bare. EFT responds by changing the question before trying to save the old grammar. First, it removes the empty vacuum and replaces it with a continuous energy sea. Then it removes the point particle and replaces it with a closed, locked, self-sustaining structure formed inside that sea. Then it removes the idea that a field is an extra floating entity and translates it into a sea-state map. Even renormalization is pushed back down into scale handoff, coarse graining, and recalibration. Once that rewrite is made, the high-energy, short-distance regime is no longer read as a pathological collision between featureless points in an empty background. It is read as a stressed substrate undergoing structural reorganization. In one region, tension is driven toward its limit. In another, boundaries begin to take command. Elsewhere, local thresholds are tripped again and again. Stable structures can unlock, dissolve back into the sea, and regroup into new forms. What used to look like the formulas starting to smoke now looks, in EFT, like a real machine finally entering its harshest working condition. One that was never going to be faithfully described by the language of tiny ripples. That shift also changes what nonperturbative objects are allowed to mean. They no longer have to appear as mysterious mathematical residues hiding behind a geometric shell. They can be understood as genuine material layers, boundary layers, dense soup layers, and reorganization corridors. A black hole is no longer a point singularity plus a zero-thickness horizon. It becomes a machine that can breed, vent pressure, pulverize structure, and rewrite what falls into it. Strong coupling is no longer just a polite way of saying we cannot calculate this. It becomes a sign that different objects have dropped into the same deep substrate and can no longer be treated as barely nudging one another. One guardrail is essential here. EFT does not claim that this episode hands over a universally accepted final UV equation for gravity. It offers a mechanism route instead: change the substrate, change the object, change the language of scale, and many of the old pathologies stop looking like the only story that can be told. Perturbative tools are not being thrown away. In calm windows they remain sharp, efficient, and valuable. The warning is different. Do not demand that a ruler designed for ripples explain the inside of a pressure cooker, a volcanic throat, and a tidal machine at the same time. The reason the UV and nonperturbative problem feels so severe is not only that the formulas are hard, it is that the starting ontology may be wrong. If you begin from empty background plus point object, the deeper you go, the more it can feel like chasing a shadow that keeps exploding in your hands. If you begin instead from a continuous base layer, structured objects, and extreme zones ruled by boundaries and reorganization, then the places that once seemed to contain only infinities and silence start to reveal an actual mechanical cross-section that can be investigated. Open the playlist for more. Next episode: the problem of resolving spacetime singularities. Follow and share, and let this series of new physics explainers help you see the universe more clearly.